Hey everyone. Today's lesson on the video is going to be the second half of 6.4 in molar mass. So I just had you calculating molar masses before of compounds, counting the number of atoms, adding them up, getting the molar masses. So we're going to use that today to go a little further into another calculation, actually two calculations as we move along, and we'll get through the rest of 6.4 and 6.5 right now. So calculations using molar mass. We're going to see. So what we're going to use is this formula triangle right here, where we've got N, M, and M. It all kind of seems the same, but so number of moles equals the mass over the molar mass. And remember, moles, the number of moles, remember, if we talk about our molar mass, it would be in grams per mole, so mass over number of moles. So that's a standard thing that we saw in our last lesson, so we're going to continue along with that today. Okay, so we're going to use this formula triangle. I'm sure you've used formula triangles before. So we're going to use that to go on. So our example here is a can of Coke has 40 grams of sucrose, and the chemical formula of sucrose is C12H22O11. Question is, how many moles are there in a can? Okay, well, if we're going to find the number of moles, we know we're going to need the mass, which we have, and we need the molar mass, which we don't have. So the first step is going to be, let's calculate the molar mass of sucrose. So I personally like to lay out my questions like this. It's easy for me to mark number one, and it's easier for you to get partial marks as you go along. So step one, molar mass of sucrose. State what it is you're finding. Right, 12 carbons times 12.01 grams per mole, the molar mass of carbon, 22 times 1.01 molar mass of hydrogen, 11 times 16 molar mass of oxygen. This step right here, in between, it's up to you. You can put this, you don't have to. 144, 112. Each one of these, add them together, our total molar mass is 342.34 grams per mole. So now that we have the molar mass, capital M, and we have lowercase m, we can put those in. And step two, stating what it is, number of moles of sucrose is what we're finding. So N equals the mass over the molar mass, 40.0 times 342.34. I'm sure our decimal comes out a little bit further, but remember, we're only using three significant figures because there's only three significant figures is the lowest number in our calculation. 40.0, three significant digits, so I got to have three significant digits in my answer. The book will write it like this. They don't like to have fraction of under a fraction, so 40 times 1 mole over 342 grams, because in 1 mole there are 342.34 grams for sucrose. Okay, so that cancels out the gram units, leaves you just moles. Same answer, so we got to make sure that we have it properly labeled in terms of significant digits. All right, so that's the first one, using the triangle. So let's look at another example together. Sorry, I should have a bigger whiteboard, but if we got 1 liter of blood has 4.0 millimoles of glucose, which we know is C6H12O6, so you biology people, and we want to know what mass of glucose is present. Okay, so again, in this particular one, we're going to be looking for the mass. So we talk about our formula triangle, number of moles, mass over molar mass. So in order to get that, we're going to need to use that triangle again, that same one. So in this particular one, we know that if we just draw our little triangle to keep ourselves remembering, lowercase m, capital M. Okay, we're looking for the mass. So we're going to need the number of moles, and we're going to need the molar mass. So you do a couple things first. Step one, I'm going to do molar mass of glucose. Capital M equals, we're going to have 6 times 12.01 grams per mole. Yes, you have to write the unit every time. Plus 12 times 1.01 grams per mole. Plus 6 times 16 grams per mole. You can put the in-between step if you want. The answer is 180.18 grams per mole. Okay, I've got the molar mass. So now my next thing is number of moles of glucose. Well, right now I have 4 millimoles equals blank number of moles. So we know that 4 millimoles into moles, we're going to divide by 1,000. Okay, so 4 divided by 1,000, because it's a factor of 1,000. Sorry, that's kind of sideways. Factor of 1,000. In order to get moles from millimoles, that's going to give me 0.004 moles. You can write it in scientific notation as 4.0 times 10 to the negative 3. That's fine as well. That's what the book's going to do. Now that I have my conversion done and I have my number of moles, third one is mass of glucose. So mass equals number of moles times molar mass, or 0.004 moles times 180.18 grams per mole. Our mole units are going to cancel, and our answer is 0.72 grams, or, as we should probably write it, 7.2 times 10 to the negative 1 grams. Okay, so that's using the formula in a couple different ways. That's the first part. Now, the other thing we're going to do in this next part is in 6.5 is sometimes we want to calculate not just one of those 3 quantities, but we might want to consider how many atoms or how many molecules or whatever. So let's consider donuts as an example. We know that 1 dozen equals 12 donuts. Okay, I think we all know that. So 5 dozen would, if we wanted to know how many donuts were in 5 dozen, we would take 12 donuts per 1 dozen. My dozen units would cancel. 5 times 12 is 60 donuts. Okay, hopefully that makes sense. I'm sure we've seen that before. So using that kind of theory in something that's real life that we've all kind of experienced, if we want the number molecules of H2O in 5 moles. Okay, so if we've got a number of molecules of water in 5 moles, then we know that we've got 5.00 moles times, we know that in each mole there are 6.02 times 10 to the 23rd molecules in 1 mole, per 1 mole. My moles are going to cancel. 5 times 6.02 is going to give me 30.1. Oops, sorry. Important part here. Times 10 to the 23rd molecules, and change that to scientific notation. What I'm supposed to do there. 3.01 times 10 to the 24th molecules. Okay, so hopefully we can follow that logic. It's going to lead us to this next formula we're going to use, where N equals N times N subscript A. So this N right here is the number of entities whether it's molecules or atoms or ions in our case, but it could be, pumpkins, elephants, beans, whatever. Lowercase n is still number of moles. And Na is Avogadro's constant, or Avogadro's number, which we hopefully know is 6.02 times 10 to the 23. Okay, so that's our next formula we're going to work with. So from there, we're going to do a couple examples before we wrap up. Okay, so let's go to those right now. Okay, the first one is number of atoms in a 1 kilogram bar of gold. Okay, so how many atoms are in there? Okay, so if we want to find number of atoms, we're going to want n equals n times Na. Well, Avogadro's number is a constant, so I know I have that. So I need the number of moles, which currently I don't have, but I do have the mass. So my first step then is going to be the number of moles of gold. So N equals mass over molar mass. I know my mass, 1 kilogram. Remember, we got to convert 1 kilogram to 1,000 grams. Okay, it has to be in grams because the units for molar mass are in grams per mole. And molar mass of gold is 196.97. Cancels my grams, and that's going to give me 5.0760 moles. Okay, so I've got my number of moles. Now, you're going to see here, this is more significant digits than I have in some of my previous, or in my question. The reason for that is significant digits is I want to carry all my digits with me until I get to the end, and then I'm going to have the right significant digits in my final calculation. Now that I have the number of moles, step 2 is number of atoms of gold. So N equals number of entities, is number of moles, which is, insert that number, 5.0760 moles times my 6.02 times 10 to the 23rd. And in this case, it's atoms per mole. Okay, my moles are going to cancel. Multiplying those two numbers together gives me 30.56 times 10 to the 23rd. Atoms, which in scientific notation is 3.056 times 10 to the 24th. And now significant figures comes into play. This one's got a whole bunch of significant figures, 1, 2, 3, 4, 5. This one's only got 3, so I have to have 3 significant figures, which means this is 3.06 times 10 to the 24th atoms. Okay, so in this case, combining both of the formulas we learned today, so N equals M over M, and then N equals N times Na. I know it sounds like I just said the exact same thing, like 6, 7 times. Now, the one difference, this is kind of a long question, if we're using, that's if it's in just one atom. Now we're going to use a set of molecules, so we're going to have C6H5CHO, which is a flavor component. I think it's almond flavor that they put in things. We want to know how many of each atom in 26.5 gram sample. Okay, so here's our chemical formula. We want to know how many of each of these atoms. Now there's carbon, hydrogen, and oxygen. So we've got to figure out how many carbon atoms, how many oxygen atoms, and how many hydrogen atoms are in this particular one. So first thing we got to do in this particular one is hopefully realize we're going to find number of atoms. We've got a mass again, so similar to the one we just did, got to find the molar mass. So step one, molar mass of C6H5CHO. Okay, molar mass. So capital M equals, you can add them together here, so there are a total of 7 times 12.01 grams per mole plus 6 times 1.01 grams per mole plus 16 grams per mole. So the 7 here, that 7 comes from, because there's 6 carbons here plus 1 more is 7, 5 hydrogens here plus 1 more is 6, and just the 1 oxygen. Okay, you can do the calculation yourself, but it comes out to 106.13 grams per mole. Okay, so I've got my number 1, got my step 1 title. Perfect. Okay, from there, now that I know my mass and my molar mass, the second thing I can do is find the number of moles of C6H5CHO. Oops, sorry, almost lost the board there. And equals the mass, which is 26.5 grams, divided by 106.13 grams per mole. Grams cancel. That is going to give me 0.24969. Again, we're going to carry those digits because we're in the middle of the calculation. We don't want to round here, we want to round afterwards. Okay, so now I'm going to go to step 3, and so far it's exactly the same. So we're going to figure out how many molecules. Okay, the number of molecules, C6H5CHO, capital N equals N, number of moles, 0.24969 moles, times Avogadro's number, 6.02 10 to the 23rd, molecules, that's what we're looking for in this one, per mole. Moles cancel. That answer is 1.503 10 to the 23rd. Okay. So what I've been able to do now is find the molar mass of the substance I'm using, use the mass and the molar mass to find the number of moles, find the number of moles, take the number of moles and multiply it by Avogadro's number to give me the number of molecules. So there are 1.503 times 10 to the 23rd molecules in a 26.5 gram sample. Now the question asks me, how many of each atom? So step 4 would be number of carbon atoms. Okay, number of carbon atoms. So in that one, I'm going to take, we know that there are, in each, for all of these, that there are, for each molecule, there are 7 carbons, 6 hydrogens, and 1 oxygen. So what I'm going to do is I'm going to take the number I just had, which would be 1.503 times 10 to the 23rd molecules. So I'm going to multiply that number times 7 atoms for every 1 molecule, which is going to cancel this guy for me. And when I multiply that out, it's going to be 10.522 times 10 to the 23rd. And now it's atoms is what I'm left with, which in scientific notation now I got to round it, 1.05 times 10 to the 24th atoms. Okay, So it wouldn't be done yet, but I'm out of whiteboard space, so I'll just explain it. Step 5 would be number of atoms, number of hydrogen atoms. So again, it'd be 1.503 times 10 to the 23rd molecules times 6 atoms per molecule. Get that answer. And the last one would be number of oxygen atoms, 1.503 times 1 per molecule. So it'd be 1.503 times 10 to the 23rd atoms. Okay, hopefully that makes sense. So what I'll do is put the notes for 5.5 up, or sorry, 6.5. Put those up. So now what I'd like you to do is you finish the questions up to just those compounds before it said calculations involving molar mass. So you're going to do the rest of the questions in 6.4 as well as the questions in 6.5. So it's Tuesday. This is a pretty important one, so probably come back Thursday, if not Friday at the latest, with another lesson. So a few people have, actually only one person has sent me a question. So what I did is I wrote it up on the whiteboard and took a picture of it and just sent you the solution. So if you have questions like that, please send them and I'll get to them as soon as possible. Okay, guys, good luck with that. This is super important because all our calculations going forward are going to be based on these two formulas, especially number of moles equals mass over molar mass. That's a really, really important one. We use it a ton and we'll continue to use it as we go along throughout the rest of the year. Okay, so make sure you try all the questions and send me any that you might have trouble with. Okay, thanks. Bye.